Hello everyone, I welcome you all in this amazing session of yours and yours only channel, Gate Academy Global. So today I'm going to give some big announcements as you have been knowing them, but I want you to tell it to each and every one of your friends. And let me also assure you that by the end of this session, you will be very much equipped with the solutions of Gate 21 and 22 problems which were asked from RAC subject, refrigeration and air conditioning. So without any further ado, let me give you what you are looking for and what you want the most. So let's see. This is the biggest announcement yet of the year by Unacademy in the form of Unacademy Combat. So this is Unacademy and Gate Academy joint venture, and Unacademy Gate Academy joint venture in the form of gamified scholarship test. Yes, in the form of gamified scholarship test you are going to get for mechanical engineering, civil engineering, electrical engineering, electronics engineering, chemical and CSIT. So all of them we are observing this. This you can use, you can avail, you can access, you can unlock, whatever you want to say, you can say, and you can do it by applying this code. And this code is GA1111. Gate Academy 1111. So GA1111, that is the code which you need to, which you need to apply to access this, to unlock this Unacademy and Gate Academy Combat. So this is very important. You need to go through this. Anyways, this test is going to be of 60 minutes duration, right? 60 minutes duration time is there. 1 hour test is there. And in 1 hour test, it will be from 11 a.m. to 12 p.m. of course. 1 hour, 25th. That is the coming Sunday. You please enroll now because the benefits are enormous, worth 30 crore rupees. And 100% scholarship is given to top 100 students. Next 400 students shall be provided with 50% of scholarship, and 30% of the scholarship in the fee, of course, will be provided to 4,500 students, next 4,500 students. And then 20% is for those who are obtaining 80 percentile in their paper. So this is how this module is going to be. And the net total is 30 crores. So this is the big announcement. Of course, Gate Academy, Unacademy Combat. It's a gamified, I have told you, scholarship test from mechanical engineering, electrical engineering, civil, electronics, computer science, and chemical engineering. 1 hour test will be conducted on 25th of September. Yes, on 25th of September, this shall be conducted. 11 a.m. to 12 p.m. Please use this code to unlock it. And I have told you 30 crores worth of a scholarship. So this scholarship, almost we are providing everything to everyone. I mean, something is being obtained by everybody. That's the whole, crux of this scholarship exam. And there are big and huge and enormous rewards for top 3,000 rankers, such as there will be a refund in the college fee for 1 year, for whole year. Yes, the fee, college fee of whole year shall be refunded by us. MacBook Air will be given, iPhone will be given, Dell laptop is there, Samsung mobile is there, plus gate registration fee will be refunded. And the topmost 500 lucky participants, they'll be getting an Amazon voucher. So you have to enroll it now. If you have not enrolled it, just go and enroll it. And if you have enrolled it, I would like to say that please recommend it to each and every one of your friends. That is very important. Okay, this is pretty much it about the announcement. Now I would like to proceed further with the questions of RAC. And here is the first question. See, I have included some thermo questions as well, right? Some of the problems from thermodynamics, they have been included as well. And the reason why they are included is because of the fact that in yesterday's session, I missed out on 1 or 2 questions. So they are included over here. So this is a problem from thermodynamics itself. So please, I would like you guys to attempt this question. Then I'll give you the solution, of course. But first, attempt it out. Do it, please. जी, सो चलिए देखते हैं इसे। सबसे पहले इसने कहा क्या है, ध्यान दीजिए। इसके अनुसार एक सॉलिड स्लैब है 0.1 मीटर्स थिकनेस, है ना। 80 डिग्री सेल्सियस टेम्परेचर है ए साइड का। बी साइड का टेम्परेचर हमें नहीं पता कितना है, टीबी मान लेते हैं, है ना। यहां से जो हीट फ्लक्स है जो कि निकल रहा है, आई मीन माय हिंदी केम आउट, आई एम रियली सॉरी फॉर दैट। Actually, it is the mother tongue, so it comes out all along. And it is the very first response which comes out. I'm really sorry for that. So let me tell you, a slab has been given, and on one side, the temperature of the slab is given to be as 80 degrees Celsius. The other side temperature is not given. In fact, it is asked. No, it is not asked. So TB is not given. And this is the thickness, 0.1 meters. And this Q double dot, which means heat flux, has been given as 4500 watts per meter square, or 4.5 kilowatt per meter square. That is what mentioned over here. Great. And the thermal conductivity is given to be as 15 watts per meter Kelvin, right? So first things first, we need to find out the temperature of this B side, or TB. So if we want to do that, Q double dot can be written as minus K, not minus K, K A delta T over del. That is how we write it. So this is Q, not Q double dot. This is Q, right? Okay. So fantastic. Now what? If that is the scenario, then Q double dot can be written as Q by A. See, the unit is also per meter square, no? K delta T by del. So 4500 equals delta T 80 minus TB upon, what is del? 0.1, and this K will come down 15. So I think I can write 80 minus TB equals how much? This 80 minus TB is 4500 into 0.1 by 15. So it will be cancelled and it will come out to be as 300, right? and 300 into 0.1 is 30, means 80 minus TB is 30, which means TB is how much? 50 degrees Celsius. I hope it is clear. Now, S dot generation is nothing but delta S dot of the wall. And how much is this? Q by TA. It is leaving TA. That is why it will be A side, it is leaving. Yes or no? It is, if you talk only about the slab, it is leaving this surface A, right? It is reaching the surface B. So plus Q by TB. So S dot generation shall be now, Q can be taken out as common. How much? 4500. It will be minus 1 upon 380 degrees Celsius, no? 353 plus 323. So something will come. How much is that? Let us 1.18 kilowatt per meter squared Kelvin. Sir, kilowatt per meter square is not the unit. Then why it is coming in kilowatt per meter square? See, bacha, this is coming in kilowatt per meter square is because of the fact that the heat involved here is not heat transfer rate actually. It is heat flux. That is why. I hope it is done. Kindly take a screenshot. Kindly take a screenshot, then we shall be moving forward. Okay? Fine. Next up. See, this is a very easy question. I don't even have to give some time to you to do it. Anyways, which of the following is an intensive property? Density. Also, it is the ratio of two extensive. What are extensive properties? Those which depend upon the size of the system. Ratio of two extensive properties. Right. So this is the ratio of two extensive properties, and the ratio of two extensive properties is always an intensive property. Right. Right. This depends upon the size, so it won't be this also, this also. They all depend upon the size. That's why they are not included. Next, this question is a good one. Please try it out, then we shall be moving forward. Kindly try this, then we shall be moving forward. Okay, so let's move forward. Try this out. Now you have this. All right. Right. And the enthalpies are mentioned over here. For example, over here, the enthalpy is given out to be as 300 kilojoule per kg. Over here, it is given out to be as 250 kilojoule per kg. Yes. Nothing is mentioned. Nothing is mentioned. Over here, HF is given 50. Now we know that COP can be written as refrigeration effect upon work input. What is refrigeration effect here? H1 minus H4 upon H2 minus H1. Let us see. So COP is 3, 1 minus 4, 250 minus H4 over 300 minus 250, 2 minus 1, so it will be 50, 50 into 3, 150, H4 shall be 100, right? Now, this value of H4 can be written as HF plus X times of Hg minus HF. Am I right? H4 is HF 50 plus X times 250 minus 50. Am I right? Now what we are getting? 100 equals to 100 minus 50 upon this shall be 250 minus 50. That is your X. Now the value of X coming out to be as 1 by 4. So this 1 by 4 shall be 0.25. Am I right? X shall be 0.25. That is the answer. I hope you have understood this, right? X value is coming out to be as 0.25. The value of X is 0.25, of course. Am I clear? Right? So kindly just copy down or take a screenshot simply. No need to copy down this lengthy part. Take a screenshot, then we shall move forward. Okay, I think ample amount of time was given. Next, this question is damn easy. Try it out. It's a very good question. Try it out, please. चलिए नेक्स्ट देखते हैं हम लोग. वेपर कंप्रेशन रेफ्रिजरेशन साइकिल है. I mean, again Hindi came out, I'm sorry. Let's see the next part. I mean, this is the condenser, right? That is your compression. This is the evaporator. This one is throttle valve. Okay, 1, 2, 3, 4. All right. So this is taking up heat which is equal to 150 kilojoule per kg. Am I right? This one is some work input is going in, and also this is the condenser, right? So some heat will be lost from the condenser. So now if you apply the energy balance, it will be energy coming in, total energy in equals total energy out. So now how much energy in is coming? 150 plus W in will be equal to QC. So if somehow we are able to find out this W in, all will be done. So how to find it out? Let's see. Through the help of COP we can do that. What is COP? COP is refrigeration effect upon work input. So refrigeration is COP is 10, not 3, my mistake, 10. 150 over W in. W in shall be 150 over 10, 15 kilojoule per kilogram. Am I right? So now QC shall be 150 plus 15, that is 165 kilojoule per kilogram. That is our QC. Okay? Simple. Kindly take a screenshot, then we shall move forward. Take a screenshot, please. Okay? Next question. Try this question out. It is from psychrometry, right? That is ambient air and all. Try this out, then we shall move forward. Okay, so I think this is done. I mean, tried. See, what all are given: total pressure, temperature. This is dBT actually, dry bulb temperature, and 60% RH. RH is phi. So, what is this phi? Let me give you a context as to what is the meaning of phi, what is the significance of phi. Whenever cricket matches, happening, whenever there is a cricket match going on, they always announce in terms of moisture content or humidity, and that is announced in terms of pressure, percentage, sorry. So that percentage is 60%. So RH 60%, 0.6 PV by PVS. Am I right? It is your PV upon PVS. And PVS is this. It is given now, saturation pressure at this point. So PV equals to 0.6 into PVS, that is 3.6, which means 2.16 kilopascal. This much PV is coming. Now, omega shall be 0.622 PV over P minus PV. Am I right? Now, omega will be 0.622. PV is 2.16 over 101 minus 2.16. So now omega will come. Let's see how much it is coming out to be. We'll have to calculate. Hmm. 0.01359 kilogram per kilogram dry air. But it is asking gram per. So omega shall be 0.01359 10 to the power 3 grams per kilogram dry air. So omega shall be 13.6 grams per kilogram dry air. All right. This is the value of omega. I hope it is clear. I want you guys to please take a screenshot. Then we shall be moving forward. Kindly take a screenshot and then we shall be moving forward. Do it, please. Okay, let us move forward. Next question. Oh, this is very cool question. See, 50% RH with a partial pressure PV. Partial pressure. Right. And P saturation, P set is saturation pressure at dBT or 300 Kelvin. Right. So what is phi? That is RH. Is given as PV by P saturation. Am I right? So 0.6 equals to PV by P saturation. What I believe is P saturation times 0.6 is our PV. 0.5, not 6. I think it is 0.5, right? So this shall be 0.5. Option, which option is matching? Option number A. Finish. Take a screenshot. I mean, there was no need to give time in this. I think you have taken the screenshot. Oh, last question for today. It is very interesting. I want you guys to please take some time and try this out, please. Okay, so I think this you might have tried. Let me give you the solution. Okay. Okay. So now here, please understand with the help of diagram what is happening, right? Some cold air is coming, some fresh air is coming. They are mixing up here. So they are mixing up, and after mixing, they are being sent to the room, and from the room they are exiting out, right? So they are exiting from the room at 24 degrees Celsius. We don't know the temperature over here, so let us keep it as T. 105 kilopascal pressure cold air is coming at 5 degrees Celsius temperature and volume flow rate of 1.25. Over here, fresh air is coming at 34 degrees Celsius. Then it is at a pressure of, yes, 105 only. Why? Because if same pressure is maintained, then only mixing without loss can occur, right? If you want to take out mixing without losses, so this has to be done. Next, this is 1.6 times the volume flow rate of earlier, meter cube per second. Am I right? Okay. Now, mass flow rate, m dot c, mass flow rate in of cold air, mass flow rate of cold air. If we talk about mass flow rate of cold air, P V dot RT. How much is P? 101 kilopascal. V dot is 1.25 upon R. How much is R? 0.287. Temperature is 5, means 278. Am I right? Mass flow rate of cold air. That is the mass flow rate of cold air. Now see. One 1.58236 kg per second, and mass flow rate of this fresh air will be 1.6 times m dot c. Why? Because it is 1.6 times that of cold air stream, right? Volume flow rate. So actually some temperature term will come. So what we'll do, we'll simply calculate in terms of this volume flow rate, na? 1.6 into 1.25 upon 0.287 times, what is it, 34, I guess, right? 307. Now m dot f will come out to be as, let us see how much we are getting m dot f. Two point two nine two six 2.29261 kg per second. This is the mass flow rate. So m dot cold air, m dot f we have obtained. Now please, I want you guys to take a screenshot, then we shall move forward. Kindly take a screenshot, then we shall be moving forward. Okay? Think it is done. No problem. Okay. Now, applying first law of thermodynamics for the mixing chamber. If we apply first law of thermodynamics for the mixing chamber, what are we going to get? Del Q du plus del W. this shall be 0, this shall be 0, and du will be 0. Means u final equals u initial. What will be u initial? M dot cold Cv, air it is, so Cv same, temperature of the cold air, plus m dot fresh air into Cv, temperature of the fresh air, equals to m dot cold plus m dot fresh into Cv, temperature T. Cv will be cancelled out here, yes or no? That shall be cancelled out. So m dot C will be 1 point, how much? 1.58236. How much was TC? 278, right? Then plus 2.29261 into T. So this T will come out. Let's see how much it is coming out. Okay. $295.16. Which means 22.16 degrees Celsius. All right. Now, for the room, air is taking away heat at constant pressure. So the air is taking away heat at constant pressure condition. Now what will happen? If that is the scenario, heat lost is equal to, in the room, m dot Cp m dot will be total, means 1.58236 plus 2.29261, 1.005, T out 24 minus 22.16. This is what we are obtaining. Say yes or no. Am I right? Let us find out. $7.173. Kilowatt. Okay, that is the answer coming out to be. Please check the calculations, verify the calculations. They are very important. Kindly verify the calculations, that's it. Okay, so 7.173 kilowatt is the answer coming out. So I hope it is done. I really hope it is understood. So what I want you guys to just remember this: Unacademy, Gate Academy, Combat. Just enroll it now as much as possible on 25th September at 11 a.m. This is the time when you have to go for that. Okay? And if you have enrolled, please share it as much as possible so all of your colleagues and friends know about it. See you guys in the next session. Thank you so very much. Bye bye. Take care. Jai Hind. Love you all.